Let's take one more problem on sequence detection. Here we have to design a more FSM to detect 1011. Again, overlapping sequences are not allowed. This is your clock for 10 clock cycles. Let's say your input X is 1 1 1 0 1 1 0 1 1 0. Now let's first try to figure out the output Z. In the first clock cycle you get a 1, so your output still remains 0. 2 is 1 and 1, so it's still 0. We have still not yet detected the sequence. 3 is 1, so it's still a 0. 4 is 0. 5 is 0. 6 is 0. Remember, this is the first instance where you get the sequence, so you assert the output in cycle 7. That is for a more FSM. Now again, your next sequence is this one here, but overlapping sequences are not allowed. Therefore, this is no longer your sequence. So your output stays 0 for the entire duration. Now let's try to design the more FSM. So remember, our target is to detect 1011. So the initial state is S0 with the output 0. So that's the reset state. So S0 is reset. So we have to go in the path to detect the sequence. So you get a 1, you move to S1, but your output is still 0. So S1 is a state which can be reached from the reset state by having the input 1. Next, you get a 0. You move to state S2 with the output 0. So S2 is a state which can be reached by having the input pattern 1 0 from the reset state. Next, S3. So from S2, if you get a 1, you move to S3, but your output is still a 0. So you have S3 is a state which can be reached from the reset state by having the bit pattern 101. And finally, from S3, if you get another 1, you go to state S4 and your output is now a 1 because you have detected the sequence. Therefore, S4 is a state which can be reached by having the input pattern 1011 from the reset state. However, this FSM is not complete because there are several transitions missing. Now from the reset state, if you get a 0, you stay in the reset state. Right? Now in the state S1, so S1 was reached if you had a bit pattern 1. Now there are two possibilities. The 0, you can get an input 0 or you can get an input 1. When you get the input 0, you move to S2, so that's done. When you get the input 1, so can you go back to some previous state? Or can you stay in the current state? You can know this by looking at 1 and 1. So is there a state in this table here where you have a state which matches to 1 1? No. So cancel the leftmost one. Is there a state which has the input 1? Yes. So you remain in S1. Now let's go to S2. S2 was a state that you reached if you had the input sequence 1 0. Now there are two possibilities. You can either get a 0 or you can get a 1. If you get a 1, you move to S3. If you get a 0, where do you go? Now, is there a state with the input sequence 1 0 0 in the table here? No. Is there a state with the sequence 0 0? No. Is there a state with the sequence 0? Yes. So that's basically the reset state. Now let's go for S3. So S3 was, you reach S3 by having the pattern 101. Now there are two possibilities. Either you can get a 0 or you can get a 1. If you get a 1, you move to S4, all good. But what if you get a 0? Now again, look for a state which has 1010. There is nothing. Is there a state with 0, 1, 0? No. Is there a state with 1, 0? Yes, there is. S2 is 1, 0. So from S3, if you get a 0, you can go back to S2 and your output still remains a 0. Now let's look at S4. So S4 is 1, 0, 1, 1. Now you can either get a 0 or you can get a 1. Now remember here, overlapping sequences are not allowed. So you can erase all this, and then you can decide where to go. So if you get a 0, you go to the reset state, and if you get a 1, you go to state S1. So that is how you design a sequence detector using a Moore machine with overlapping sequences not allowed.